What's up, guys? I apologize for not being at school today. We will be doing this lesson right here on long division of polynomials. I am at home right now, and that explains my creepy voice, right? I'm not going to be talking like if I'm talking to the whole class. I don't want to be yelling, so I apologize. Anyway, in order to understand long division of polynomials, we need to really understand regular long division that we used to do back in the 5th grade. So here's the problem. It says 67,508 divided by 21. So we first must rewrite this with the numerator inside the division box and the divisor on the outside. The next thing to do is to not really think how many times will 21 go into 67,508. That's kind of ridiculous. But it's easier to just take a look at the first digit, the 2. How many times will 2 go into 6? Oh, 3 times. Okay, so let's put the 3 right here. And we think, okay, it's kind of like a distribution problem. 3 times 1 is 3, so we put the 3 right there. And then 3 times 2 is 6, so we put the 6 right there. Now, what do we do next? We subtract. So for the sake of making it more relatable to today's lesson, let's not just put a minus sign right here. Let's put minus with a parenthesis right there. That way you could think of, okay, this minus sign, it's like if it were distributed to the 3, 7 take away 3, that's 4, right? So we end up with the 4 right here. And then distribute the minus sign right here. 6 take away 6 is 0. There's nothing there. Then what happens next is that this number comes down. So you're going to end up with a 45. And again, now you think, instead of 21, how many times will 21 go into 45? Which is pretty easy to think of. You could simply think, how many times will 2 go into 4? Oh, 2 times 2, right, will give you 4. So let's put a 2 up here, and then we distribute. 2 times 1 is 2, so you put the 2 right there. And 2 times 2 is 4, so you put the 4 right there. And of course, we are subtracting, and we're putting parentheses around that 42. So once again, it's really saying 45 take away 42, you will have a 3 left over. And what do we do next? The next digit comes down, so you'll have 30. And once again, you don't have to think of how many times will 21 go into 30. You could just think how many times will 2 go into 3. And that will be 1 time. And of course, distribute. 1 times 1, 1 times 2. 1 times 1 is 1. 1 times 2 is 2, and of course we are subtracting, put in parentheses with the minus on the outside. 30 take away 21 is 9, so we have a 9 right here. And the last digit to drop is that 8, so you really have 98. And again, just think of the first digit 2, how many times will it go into 9 without going over? That will be 4. So you put a 4 over here. 4 times 1 is 4, so put the 4 down there. And 4 times 2 is 8. Put the 8 right there. And we are subtracting. And of course, we're subtracting with parentheses right there. And we say the minus sign goes with the 4. 8 take away 4 is 4. So we have a remainder of what? What else? The minus with the 8. 9 take away 8 is 1. So we truly have a remainder of 14. Now, I hope you remember back in the 6th grade that whenever you do have a remainder, you simply put it right here over the original divisor. So the answer is 3,214 and 14 over the original divisor, which was 21. Now, if you could reduce the fraction, please do so. And in this case, we can. 14 over 21, you could reduce both by 7, giving you a final answer of 3,214 and 2/3, right? If you reduce by 7, 14 divided by 7 is 2, 21 divided by 7 is 3, so there's your final answer. That was a trip back to the 6th grade, right? Hopefully we remember that. Why? Because what we're doing today is the same exact thing, but with polynomials. So let me first start by making space here. Whoops. Bear with me, guys. I have some technical difficulties here. Okay, here we go. So let's now move this stuff to the side. And let's focus in on this one. It's done the same exact way. The top one, the one it's being divided by this. We're going to put this top one inside the division box, and the bottom one's going to go on the outside. And just like over here on this long division problem that we just did, we didn't think of the whole thing 67,500 divided by 21. We simply focused in on the first digit and the first digit, right? 6 divided by 2. Well, 2 goes into 6 3 times. So again, let's just focus in on this first part of the binomial and the first part of the trinomial. Let's not think the whole thing divided by this whole thing. Let's just look at this first part and that first part. So 6x squared and 3x. 3x times what will get us this exact value, 6x squared? Just like over here, right? 2 times what gave us that exact value, 6. 2 times 3 gave us that exact value, 6. Over here, 3x times what will get us that exact value, 6x squared. So 3x times 2x. Now, I already know that I'm going to write a 2x, but please write your x's on top of your x's, your numbers on top of your numbers, and so on and so on. Right? So I'm going to put the 2x right above the other x term. I'm not going to put it above the x squared, above the other x term. Okay? And now what happens here, it becomes like a distribution problem. 2x times 1 is 2x. So we put a 2x right here. And then 2x times 3x, that becomes 6x squared. Oh yeah, by the way, the 2x times 1, that's positive 2x, so I need a plus sign right here. So let's put a plus sign right there. And what happens next? We subtract. So we're going to put the subtraction bar, but like I did before, I want to put parentheses around this with a minus sign right here. Now that's why I put parentheses over here with the minus sign in front, because you're going to need, if it's a binomial like this is, 2 terms, you're going to have to distribute that minus sign to both of them, right? So imagine this minus sign is really here, so it's really a negative x minus 2x. That'll give you a negative 3x. And then this positive 6x squared, and if you distribute it right there, it'll be a negative 6x squared, which completely cancels out. Okay. So we've done that so far. Now next we bring down the next term, which in this case happens to be a negative 7. Bring that down. So that'll be a minus 7 right there. And then we think again, just the first term, 3x times what will get us this exact value? Now you're probably thinking, well, it's already 3x. Yeah, that's true, but we want it to be exactly the same as in with the minus sign. So 3x times what will get us that exact minus 3x? And the correct answer is negative 1. And notice that I put the 1 on top of the 7. Numbers on top of numbers, x's on top of x's. If I had an x squared, I'd put it on top of the x squares. Everything's organized. Look, x squared on top of x squared, x's, numbers. Anyway, again, I went 3x times negative 1 gives me that exact value, negative 3x. So I'm going to put that exact value, negative 3x, right there. And I want to distribute over here also. Negative 1 times 1, that's negative 1. And I am subtracting, but I need to put parentheses with the minus sign around it. That way, when I distribute negative 1 with that, negative sign with that negative, that becomes a plus. So negative 7 plus 1, that is a negative 6. So I really have a negative 6 as a remainder. Maybe I should do this in green the way I did before, negative 6. But what else? Well, yeah, that negative becomes positive, that cancels out. So that's all there is. So that's the remainder, negative 6. So what's my final answer here? This is my answer, but I must put the remainder over the original divisor, okay? So I really have 2x minus 1. I could put plus negative 6 over 3x plus 1, or I could just take that negative in front of the 6 and put it as a minus with the 6 up on top over the original divisor, 3x plus 1. So there's my answer, 2x minus 1 minus 6 over 3x plus 1. So it pretty much is identical to what we did back in the 5th grade, long division, right? It's just slightly more interesting, I would say. Now, of course, there's more to it than that. Let's do another problem. By the way, this one was number 20 on the worksheet that we're going to have for homework. But let's do another problem here, and let's actually write out the steps on how to do this. So here we go. We have another example right here. We have this divided by this. Okay, so I wrote down the steps here. You might want to get your notebooks out. Hopefully the substitute or whoever's there could hit pause so you guys could jot this down. Okay, before you copy this down, let's read it, understand it. Maybe you might want to write it in your own words. Step 1, the numerator or the first polynomial goes inside of the division box. So this guy's going to go inside of the division box. But notice it says in standard form and it's underlined. Now standard form when we had quadratics was ax squared plus bx plus c. But right here when you have a polynomial that has a power that's bigger than 2, all it means, standard form, all it means is highest exponent term down to the smallest, including terms with coefficient of 0. That means that you want your highest exponent term first, the 2y to the third, and then the negative y squared, and then you see how there's no y? You'd have to represent the y as a 0y. Again, once again, you want highest exponent first. That's a power of 3, power of 2. Where's y to the power of 1? It's not there, so you're going to have to plug it in as 0y, and then the constant at the very end, the 25 at the very end. And of course, the denominator, or the polynomial you're dividing by, this guy goes on the outside of the division box. And then after that, you just divide the same way you would back in the 5th grade. So I hope it's been paused. I hope you guys copied this down already. If not, you could rewind a bit and then pause it. And let's actually work through this example following these steps. Okay, so step 1 is to write this guy in the inside of the division box. So here's my division box. And what we want to do is rewrite it in standard form, highest exponent down to smallest, representing every single power. So the first power, the highest power is 3. I need to write that term first, 2y to the third. That's my first term. And then I have my minus y squared. That's my second term. Now I am missing the y to the 1 power. There is no y to the 1. And it was all out of order anyway. So 2y to the third minus y squared. It doesn't have a y to the 1, so I'm going to put it in as a plus 0y to the 1, or just plus 0y. And at the very end, I have my plus 25. So that's my first polynomial inside of the box in standard form, 3, 2, 1, constant, the number at the very end without the variable. And this polynomial, which is technically a binomial, goes out here in the front. This is what I'm dividing by. This is my divisor out here. So it's really a y minus 3. So I hope you guys understand how to set it up. And now, just like back in the 6th grade, or 5th grade, whatever it was, you don't look at the whole thing. You don't look at this whole cubic polynomial, this giant polynomial divided by y minus 3. You just look at the first term and the first term. So if I just focus in on the y and the 2y to the third, I'm really thinking y times what will get me that exact value, 2y to the third. So y times 2y squared will give me that exact value, 2y to the third. Again, y times 2y squared will get me that exact value of 2y to the third. Isn't that right? Imagine 2y to the second times y, that's going to be a 2y to the third, and it gave me that exact value. But then again, you have to distribute, right? It's not just about that one times that one, this one times this one. So 2y squared times negative 3, that'll be a negative 6y squared. And again, it's important to notice that when I first decided y times what gives me the exact value, 2y to the third, it's y times 2y squared. And notice where I put it. I didn't put the 2y squared on top of the y to the third. It has to be all organized. Y times 2y squared, I wrote that 2y squared right above the other y squared terms. That way all the y squareds are lined up perfectly organized, all the y to the thirds are lined up perfectly organized, and so on and so on. Anyway, once we distribute to both terms, we get this binomial, and we are subtracting. So let's put the subtraction bar, and let's put parentheses here with the minus sign out here. Now why is that? Because I need to distribute it to both, which means that this becomes positive 6y squared. Positive 6y squared, take away 1y squared, right? That'll give you a positive 5y squared. And over here, that becomes a negative 2y to the third, which cancels out with the positive 2y to the third. What do I do next? I go to my next term and I bring it down. So that will be a plus 0y. And after that, again, you go to this first term y and this first term y, 5y squared. Y times what will get me that exact 5y squared? Y times 5y will give me that exact 5y squared. Again, y times 5y, and that is a positive 5y, will give me that exact 5y squared. Again, y times 5y. 5y times y gives me that exact 5y squared. Distribute to the other term, 5y times negative 3. That'll give me a negative 15 with a y. And of course, we're subtracting. So put the subtraction bar, put parentheses, put the minus sign. Distribute the minus sign. This becomes a positive 15y. A positive 15y, but when you add 0y, it's still positive 15y. And of course, when you distribute over here, minus 5y squared, that'll cancel with a positive 5y squared. Last but not least, bring down that 25. So I have a plus 25 right there. And once again, y times what will get me that 15y, that identical value 15y. Y times 15, positive 15, will get us a positive 15 y. I guess I'll keep writing it in red. Sorry, I messed up on the colors. And 15 times negative 3, that's negative 45. And of course, we're subtracting, so put the parentheses with the subtraction. So that means that this really becomes a positive 45. So positive 45 with the positive 25, when you combine it, positive 45 and positive 25, that is positive 70. You don't have to put the plus sign, but you could if you want. And of course, over here, this minus 15y cancels with the other 15y. So this is my remainder, okay? So my final answer will have plus the remainder 70 over the original divisor, which happened to be the binomial y minus 3. That's what I was originally dividing by. So this is my answer to this division problem. Here's the worksheet that we're going to be working on the rest of the period. But before I let you loose on the worksheet, I do want to mention that these same type of problems could look weighed really differently. Like number 5, this power of negative 1 would mean that this 4a goes down underneath and it becomes a division problem. So this really goes inside the division box. This one goes in the denominator on the bottom, or outside of the division box. And even before doing long division, ladies and gentlemen, you should try to simplify your polynomial first. Like, for example, right here, it looks like we have 3 terms, but in reality, it's only 2 terms, because negative 8a squared could be combined with positive a squared. Cannot combine a to the thirds with a squareds, but you could most definitely combine a squares with a squares. So please simplify first, even before doing long division. You know what? It's best that we just go over several of these together. Number 1, let's actually see on this one. Here's another special problem. I wouldn't really just start by putting this inside the division box and representing every single r, like r to the 9th, r to the 8th is right there, r to the 7th, r to the 6th. That's a lot of work. Right now, what I recommend doing is, if you have a polynomial up here and something down here that's a monomial, in other words, one term, try to factor out a GCF. That way you could get multiplication to cancel. Okay, I know if you're thinking, what the heck's he talking about? Well, it's this simple, guys. If you have 3 plus 2, which is 5, and you divide by 2, you can't really do that. The answer is 5 divided by 2. But if you had 3 times 2 divided by 2, we just learned on the previous section that when you have the same identical thing over the bottom, same identical thing, you cancel it out. See right there, the 2's do cancel, and the answer is 3. You guys remember that you can't cancel when there's addition or subtraction, but you could cancel when there's multiplication. So the deal is this, like right here, I see a 15 up here, even a 15r to the 10th, but I cannot cancel the 15 with the 5. And I can't cancel these 10 r's. I cannot cancel it with these 4 r's. Why not? Because I have a minus something and a plus something. And whenever you have addition or subtraction, you cannot cancel, right? When you have pure multiplication, then you could cancel. So we would need pure multiplication. So What I'm getting at here is I could factor out the GCF from the numerator, which would be the coefficient 5 and also the maximum r squared. So the GCF would be 5r squared, and on the inside of the parentheses what we would have left is 3r to the 8th minus 1r to the 6th, and then plus 8. That's it, no r's. That's what we have on top. And on the bottom we still have this divided by 5r to the 4th. So what did I do? I had subtraction and addition. Now I really do have something times something. And this outside something, I want to cancel it with this bottom something. So this 5 and this 5 will cancel out. The r to the second on the top, 2 r's will cancel with 2 of these r's, and you'll have 2 left over. So your new problem becomes, and we should know that the numerator goes inside the box, but remember I said you have to represent every single power. R to the 8th, you'd have to have a plus 0r to the 7th, minus 1r to the 6th, plus 0r to the 5th, plus 0. So it gets really ugly. Let's try to not do that giant mess. Let's do this. Let's see if we can do this. Let's put 3r to the 8th. Let's just leave some space, minus 1, r to the 6th, leave some space, plus 8 at the very end. Let's see how this works. I'm not sure. Let's see. And of course it's divided by r squared on the bottom. So when we think r squared times what will get us a 3r to the 8th, that will be 3r to the 6th. All right, that works out nice. So I'm going to put the 3r to the 6th right above the other r to the 6th. And when I multiply 3r to the 6th times r squared, that is 3r to the 8th. And normally I put the division bar with the parentheses with the subtraction. That's mainly when I have a binomial, so I don't forget to distribute the minus to both terms if it were a binomial, right? But since we were dividing by one single term, when we multiply, you didn't distribute, you end up with one term down here. So 3r to the 8th, take away 3r to the 8th, that's 0. And then you take your next term and you bring it down, so that's a minus 1r to the 6th. Now the question is, r to the second times what will get us that exact negative 1r to the 6th? Well, that would be a negative 1r to the 4th, right? Negative 1r to the 4th times r squared will give you a negative 1r to the 6th. So let me write that, negative 1r to the 6th. And of course we are subtracting, so we put that in parentheses with the minus. And that really becomes plus, and that cancels out. So what do we do next? We take the 8 and bring it down as well. So we have plus 8 or positive 8, and then you ask yourself, r to the second times what gets us 8? Well, you can't do it, right? So this is technically your remainder. So your answer is 3r to the 6th minus 1r to the 4th plus 8. So I'm going to put plus, but I'm going to put a fraction with the 8 up on top because that's your remainder. The remainder always goes over the original divisor, r squared. Ladies and gentlemen, this is your answer for number 1. Now, again, notice that I didn't worry about doing every single term, the 0r to the 7th, the 0r to the 5th, the 0r to the 4th, 0r to the 3rd. I kind of left space just to see how it would work out, and this one worked out fine. Now, you might need to do it. You might need to do the 0r to the 7th and so on and so on. Let's try a different one. So that one, I'll be honest with you, that one's kind of weird because you didn't have a binomial down here. Let's go to one that actually has a binomial down there, like number 18. So let's look at number 18 and let's set it up the way we're supposed to. Again, you have to understand this first. This is really being moved to the bottom, which means that you have this top polynomial divided by this binomial. Remember, the power of negative 1 really means that you must grab that whole term and move it down underneath. So it's really that top one divided by 2y plus 3 on the bottom. So setting it up, the top one does go inside the divisor, inside of the division box. 6y squared minus 5y minus 15. And the 2y plus 3 that you're dividing by goes out here. And again, you focus in on your first term. 2y times what will get us exactly that 6y squared. So 2y times 3y will get us exactly that 6y squared. So 2y times 3y will get us that exact 6y squared. But again, we have a binomial here, so you need to distribute it. Now 3y times 3 is 9y, and that'll go right here, 9y. Positive 9y. So you're subtracting, put the parentheses, put the minus sign out there. If you were to distribute, minus sign goes here. That's a negative 9y minus 5y. That's a negative 14y. Negative 14y. Of course, the negative 6y cancels with the positive 6y. Then we move on to the negative 15. Bring that down. So we have negative 15 right here. Then go back to your first term. 2y times what will get us that identical negative 14y? That's going to be a negative 7. 2y, the negative 7 times 2y gives us that identical negative 14y. And then negative 7 times 3 is negative 21. That goes right there. And again, we are subtracting, so let's put the parentheses with the minus sign. That way we remember to distribute the minus to both terms. That's really a plus 21 when you distribute. Negative 15 plus 21, that's going to be a positive 6 as your remainder. And obviously, this becomes positive, which cancels. So this is your remainder. So your final answer for number 18 is 3y minus 7 plus that remainder over the original divisor, 2y plus 3. So there's your final answer. 3y minus 7 plus the fraction 6 over 2y plus 3. Let's do one more, then you'll be on your own, okay? Let's do 23. That one looks crazy. Why does it look crazy? Well, first of all, it isn't from highest exponent down to smallest, but it is missing some values. Like there's no p to the third value. P to the fourth, where's p to the third? It's missing, so you'd have to put plus 0 p to the third. And then you got the p squared, then the p. So let's do this one. We're going to divide the top, the 4 p to the fourth. There is no p to the third, so let's put plus 0 p to the third minus 17 p squared plus 14p minus 3. Okay, and we are going to divide this by the denominator 2p minus 3. Again, you look at your first term, the 2p, and look at that first term, 4p to the fourth. 2p times what will get us that 4p to the fourth? Well, 2 times 2 and p times p to the third will get us the 4p to the fourth. Okay, and notice that I put it on top of the other p to the third. Okay, if I wouldn't have put the 0p to the third, it wouldn't be here, so I'd kind of get unorganized here, right? So it's important that we put those missing values, the 0p to the third. So anyways, 2p to the third times 2p gets us that exact value, 4p to the fourth. Let's distribute 2p to the third times negative 3. That's going to be a negative 6p to the third. Negative 6p to the third. Now we are subtracting, so let's put parentheses around this binomial with the minus sign. Distribute, that's going to become positive 6p to the third with 0p to the third. That's simply positive 6p to the third. And of course right here this canceled out. Bring down the minus 17p squared. That's your new binomial that you're dealing with. Maybe I should put it all in blue. Stay consistent with my coloring here. And then I have 2p times what gets us that 6p to the third. Well, 2 times 3 would give me the 6, and p times p squared will give me the p to the third. So that will be a positive 3p to the second. Once again, 3 times 2 is 6, so I put the 6 down here. P to the second times p is p to the third, so it's 6p to the third. And then 3p squared times negative 3, it's going to be a negative 9p squared. So it's a negative 9p squared. Of course, we are subtracting, so that means you got to distribute to both terms. Hey, Benji, wake up. Okay, anyway, sorry about that. So we need to distribute that minus sign to both terms, and this becomes a positive 9p squared with that negative 17p squared is going to give you a negative 8. Sorry about that, negative 8p squared. Bring down the 14p. Man, my coloring just went way off. Whatever. Just keep going. And then think 2p times what will get you that negative 8p squared. So 2p times negative 4p will give you that exact value, negative 8p squared. And then distribute that negative 4p also times the negative 3. It's going to be a positive 12p. Of course, I'm subtracting. Put the parentheses with the minus sign. And distribute to both terms. This becomes negative 12. So 14 take away 12 is 2p. So you have 2p left over. Bring down that minus 3 at the very end. Minus 3. 2p times what is 2p? 2p times positive 1 is 2p. And then that 1 times negative 3 is going to be negative 3. Wow. Pretty cool, because at the very end you have the remainder of 0, which means that this is simply your answer right there. Yes, that was definitely a lot of work that's long, which is why we call it long division. All right, I'm stopping right here, but you're not. You're going to work on the rest of these. I would say to do the rest of these, the ones that you have division of a binomial, try those. And you could skip, skip the top ones. Let's just do 19, 20, 21, 22, and 24. I already did 18 and 23 for you. Do your best. The answers are on the back of your worksheet.